All right, thank you. Hey, hi everyone. Thanks for joining us today at Microsoft Reactor. This is actually the first session in our new AI Genius series, season 4, and I'm really excited to be here. My name is Rakesh Lakshminarayana. I'm based out of Melbourne, Australia. I am a principal AI consultant at Agile Insights. About me, I work with customers on everything from solution design to writing code using Microsoft Tech Stack, and that includes Azure, .NET, and of course AI, which has been the center of almost everything we do these days. And today we will be talking about Microsoft Agent Framework, and which is actually the open source framework from Microsoft for building agentic applications. And the framework has actually reached general availability, which is actually a big milestone. So it's a great time to start building applications using this framework. All right. So this is actually what we have planned for the session today. We'll start with the foundations, going through the key concepts of agentic applications, and then we will have a brief overview of the Microsoft Agent Framework, and then we'll move on to the demos. And the demos are actually split into two parts. In the first part, we will have some focused examples to do a deep dive into the concepts like context management, skills, and tool integration, all using a Microsoft Agent Framework. And in the second part, we will have a demo of a full travel assistant. And this is actually the application where we bring everything together, and that demonstrates a more complete end-to-end experience. We will wrap up with some time for Q&A at the end. And we also have Michelle Sanford and Aaron Powell with us today, and they will be helping us with the Q&A. So please feel free to drop your questions in the chat while we are going through the session. All right, so let's get started. So let's actually go through some of the basics to start with. All right, an agent at its core, it's actually a system that can work autonomously and perform the task, and it needs a language model, tools optionally, and memory. A language model is going to be the brain, and it helps the agent understand the queries, reason about them, and also generate responses. And tools are the agent's access to the outside world, and it could actually be anything it needs to fetch data or take action. And memory is what gives the agent the context it needs to work with. But so when you move from a prototype to an enterprise grade application, so there are a few more things that you need to think about. And that's what you see mostly on the right side of the slide. Guardrails are going to be critical, and this is to actually reduce the blast radius of any unentered actions by the agent. So the way it works is you assign an identity to the agent, and you use that to control what resources it can access and what tools it can call. Right. So if your application has some sensitive actions, you could probably look for an approval workflow where an agent requests a user for approval before it goes and executes a tool. And this actually builds trust and safety into the system. And you also would need audit trails, and this is actually to track or understand the agent's access patterns or execution patterns, and to also meet the compliance requirements of the organizations. And model calls and tool calls can actually become expensive if they are not managed properly. So you need strategies in place, such as selecting the right model for the right task, or keeping the context lean, and also caching the tool responses so that you avoid redundant calls going to your servers or tools. And observability is also one of the key requirements. So you need to have full traceability of the agent's actions, and what was in the context, what tools were called, and what responses were generated. And this is actually critical information that you would need for debugging and also improving the agents over time. So testing an agentic solution is actually different from testing a normal software or traditional software, right? So because you have the non-deterministic language models in your solution, so you need systems in place to continuously evaluate the quality of the response and also improve them over time. And as you scale your application, you'll have multiple agents working together, and you need the plumbing in place so that it would establish the communication channel for the different agents to share information and also collaborate on the task. All right. So the core concept behind any agentic application would be the agent loop. So this is the continuous cycle of reasoning, tool calls, and the memory updates that the agent goes through when processing a query. So let's take a simple example of a travel assistant. The user asks, when is my flight to Sydney, for example. The language model first reasons about how to answer this question and decides that it needs to call some tools to fetch the data. And the agent goes and orchestrates the tool calls, fetches the data, and the model now has the information to generate the response for the user. So it would say your flight to Sydney is on so and so, and that's one iteration of the loop, that's one cycle. And the loop doesn't necessarily always need to finish with one tool call or one loop. For a more complex query like booking a flight to Sydney and also maybe saving the details to a calendar, so the model might actually prepare a plan with multiple tool calls, multiple sources of data. So each time it gets the new information from the tool response or from a source, it needs to update its context, and it also needs to reason about the next step. And this loop would actually continue until the model has enough information to generate a final response. And managing this loop can get complex very quickly as you add more detail and also more scenarios in your application. Microsoft Agent Framework provides the building blocks and also the abstractions that are needed to handle this kind of complexity. And so that you would focus more on building your application logic rather than the underlying plumbing. So a few things that are worth highlighting here about the framework. It's an open source SDK, and it supports both .NET and Python languages. And it's designed to be extensible, which means you can actually swap memory providers or models without rewriting a lot of code. And it's more like a plugin architecture. You also have middleware support that you can introduce to intercept some of the steps in the execution path. And it's built on open standards. It supports MCP A2A for agent to agent communication, and also AGUI. We will be looking at AGUI in the later slides or later demos. It also supports open telemetry standard for observability, so you can trace the conversation, tool calls, and the end-to-end data flow throughout the system. And it also supports flexible options for hosting your agents. You can publish your agents as OpenAI compatible endpoints as well, which means if you have any client that's already talking to OpenAI service, you can point to your agent without changing the client code. All right, so now let's actually move on to the demos. Right. The link to the documentation is actually shared with you on the chat. It should take you to this page. Let me bring that up on the screen quickly. Right. So this page has all the information about the demos that we'll be doing and the final application. And there is a link called Environment Setup Guide, which has the instructions on how you would set up your environment for running these demos. And here's the list of all the tools you will need. We will be using .NET and C#, and you will need .NET 10 SDK installed to run the code examples. The front end is a React application. Azure Developer CLI is used for creating and managing resources on Azure. And we will be running the application on containers. So we need a Docker to be installed to build and run the container images. Aspire is a great tool. I mean, it's actually very useful when for your development experience, especially when you have multiple services and dependencies in your solution. And it gives you one command where you run everything, and it also provides you a dashboard for viewing the logs in one place. All right, I already have the environment set up, but I'll walk you through the steps quickly. So you can fork this repository into your own GitHub account, and you can actually open it using GitHub Codespace. So with GitHub Codespace, you don't need to install everything manually. It comes like a pre-configured environment for you where you can actually start working on the code without worrying about all the hassle of installing the framework and things. And all the files related to the infrastructure is under the infrastructure folder after you clone your repository. So this is where you would find the infrastructure files. I'm using biceps for the infrastructure code. And once your code space is running, you would actually start with setting up your infrastructure by first authenticating to Azure. And you would use the ACD auth login command. You would then create some environment variables, and then you would finally run the ACD provision command, which creates the resources on Azure. And you would then run this script to provision some mock data in Cosmos DB, which we will be using in our demos. And we also have the instructions for running Aspire dashboard on this page. We will be using Docker for running the Aspire dashboard. And yeah, so you can actually run Docker containers on your code space as well. So let me just quickly go back. AZD deploy would be the command which would you would run to finally deploy the application to the Azure. And for running the application locally, you build the application using this command, and you would then run aspire run command to run the application host. So I have started that aspire run, and then you click on the dashboard link to open the dashboard, and you would see the links to all the resources here, and then you would click on the front end command to open the application. All right, so this is actually where you access the front end application. So now let's look at the architecture. So this is the deployment. This is what we have deployed to Azure. All the services are actually hosted on Azure Container Apps. The front end is a React application, and that's the interface users interact with. The backend is an ASP.NET Core application that hosts your agents endpoint. And the MCP server is actually hosted on Container App as well. It exposes the tools for searching and booking flights. And this is secured using an API key. And the agent needs to provide any key when it calls the tools. And the agent uses language models from Azure OpenAI service. Cosmos DB here is used for persistent memory. We'll see how that works when we look into the demos. And we are also using application insights for monitoring and logging. All right, so this covers the infrastructure part. Now let's look into the agent setup. In our solution, we are using multiple agents. So we have two specialized agents. So one is the travel advisor, and we also have a flight booking agent helping with the flight booking and searching. And each agent has its own tools and skills which it would need to execute the task for its responsibility. So we use Microsoft Agent Framework for the agents and the workflows. We will go deeper into the features of the travel assistant in the second part of the demo, and all and yeah, so we'll first look into the focused examples now, and all the examples are under the labs folder here. So you'll find all the examples here, and each example has a readme file, so with all the instructions on how you would be running the demo, and it also has details about the code, so you can always come back and refer to that. Okay, so now let's actually start with our first example, which is about context management. All right, as you know, language model performs best when it has right context, right? So the context could come from knowledge base, or it could be real-time data from an API call, or even it could be from your previous conversations. And instead of having one big block of code in your application that fetches all the information and builds the context, it's better to have a more modular approach. So where each component is responsible for a specific type of information. And that's exactly what context providers are in for in a Microsoft Agent Framework. So So this is how the flow of execution looks when you use context providers in your agent. I've split this into two phases, the setup phase and the execution phase. In the setup phase, the agent is created with one or more context providers, and the providers have their own logic for fetching and managing information. And in the execution phase, the flow looks like this. The user sends a query, and before calling the language model, the agent activates the context provider, and these providers inject the additional information into the context, and the agent then sends the query along with the context to the language model. And now the agent generates the response, and the agent returns this response back to the user. Right, now let's quickly take a look at the code for this. So it's under the labs folder. So the context program is what we are currently looking at. And this is actually our first example of an agent using Microsoft Agent Framework. So let's spend some time walking through the code in a bit more detail. And all the other examples in the repo also follow a very similar structure. And I'm using a file-based C# program, which is actually a new feature in C# 10 that allows you to write the entire program in a single file. So there is no main methods, there is no class that would be required, and even no project files. So it's clean and easy to follow. So here we specify the NuGet packages or the dependencies that's needed for running the program. And then we load the environment variables. This is actually the reading the file, the .env file, and it was created when we ran the azd command to set up the infrastructure and upload the code. So it reads the same details and connects to the resources that we created on Azure. And within we are using OpenAI Open Telemetry and log all the calls to the language model and the tools. And this is actually sent to an OTLP endpoint, and our Aspire dashboard is actually listening to this, and we should be able to visualize the data on the dashboard. All right, we then create a chat client, and in our example here, so we are using Azure OpenAI service, so we use Azure OpenAI chat client. You can also use other providers like Anthropic or maybe Olama. And there are different packages that you need to install for different providers. And yeah, so then you create an agent using the chat client that we created, and you pass the system instructions and the tools if in case if you need any. In this example, we're not using tools. So we will look at how to integrate tools in the next demo. And we are also using something called travel knowledge context provider here. So this example is about travel recommendations. So this provider will help with introducing or injecting the context that would be required to answer the questions. All right, so this is actually a simple class. It implements AI context provider class, and there are two methods: provide AI context method and a store AI context async method that you could actually use. Provider AI context async method is where you add the relevant context or inject the specific instructions or the guidelines for the model. And in here, I have actually added the list of destinations or options that the model can use when responding to the query from the user regarding the recommendations. And store AI context async is the method that's called after the model generates a response. And you can use this method to process the results if needed, like logging or storing them in a database. And we create a session, an agent session. It was actually called as agent thread in the past. Now it's agent session. And then use that session to interact with your agent. You send messages by using the run async method, and you can add more messages to the same thread by using the same session here. All right, now let's actually run the program. So you can run the program by clicking on the run button on the top right corner, or you can use a .NET run command. And in this example, we are actually asking for recommendations, and the model generates a response with a list of destinations. And there was also a follow-up question about what destinations would be recommended for families with kids. So it understands that it's actually a trip planning or a recommendation query in progress, and it's able to generate a response, a coherent response, right? Because it has access to the previous message in the thread as well. All right, so now let's look at the log in Aspire. So when you click on Gen AI details, you have the full trace of the execution path. So the first message is the system message, and this includes the additional context that we provided, which is the list of destinations. So this is a part of your system message, and then you can see the message from the user, the assistant's first response, and the next message from the user, and the final response from the assistant. Okay, so you can also inspect the full payload of the message that was sent to the model. So you can see like you have all the messages in the JSON. So it's the first message, the assistant's response, and the user's follow-up question. All right, so this example that we saw was to just demonstrate how context can be passed to an agent in Microsoft Agent Framework. And as we know, models have limited context window, and every token would cost money, right? So you need to be strategic about how much information you provide to the model. And in a real application, you use techniques like RAG, retrieval augmented generation, to pull only the relevant information from your knowledge base to answer the query. All right, now let's look at skills. In the previous example, when we sent the list of travel destinations, as a context to the model, right? Now, imagine that the user is asking about something else, like visa requirements, maybe instead of travel recommendations. The information that we provided is not relevant to answer that question, and it also takes up space in the model's context window. Now, skills will allow you to solve that problem, and it will allow you to load instructions and responses on demand, like instead of sending everything to the model upfront. And you may already have used skills in other tools and platforms like GitHub Copilot. And in this example, we'll see how to implement and use skills using Microsoft Agent Framework. Right, let me just go back. All right, so let's look at the execution path for skills. In the setup phase, the agent is created with agent skill provider, and this is another type of context provider that's available out of the box in Microsoft Agent Framework. And this allows to load skills from a file system. So it allows to load skills even by creating a class. But in this example, we are reading the skills from the file system. And we'll look at the sample files shortly. And in the execution phase, when a user sends a query, right, the model reviews the available skills, and it decides to load the skill called a trip planner. And agent would actually load the skill and pass that data back to the model. And if needed, it can call read skill resource tool to load additional resources. So it's not just one instruction. You can actually chain that together with additional resources, which is a part of that skill. So you can go and iterate and pull additional resources on demand. And the agent now sends the query along with the skill instruction and any additional resources to the language model. And the model generates a response using all this data, and the agent returns that back to the user. Now, let's look at how skills is actually used. So let's go to the labs folder, skills, and I have few skills that I've created for the demo today. So all the skills follow similar structure. It's a standard. It's not Microsoft agent framework feature, but skills all follow the same structure. And skills.md is the file where you would define your skill, and this file contains the YAML front matter, and which is like a metadata such as the name and the description. And this is the only information that's sent to the model. And all the details that you see below the YAML, the markdown instructions, that's actually sent. That's not sent to the model, but that's loaded on demand by the agent if the model decides to call the skill. And this file can also have reference to other resources. Like here, it has reference to the visa requirements document, which is a part of the same directory. So it loads that if there is any query that requires more information about the visa requirements. Okay, let's look at the code. It follows the same structure as the previous program that we saw, but here we are using a provider called Agent Skill Provider, which is a built-in provider from Microsoft Agent Framework. And here you pass the path to the root directory of your skill. So it's going to iterate and read all the skills under that folder and load them in the agent. Now, let's actually run this. And in this program, we're going to be asking about visa information. So this is the query that would be sent to the agent. And let's go ahead and start this. So we click on the run command. And that's the question that we are sending. We are asking about the visa requirements for an Australian citizen. And it sees that there is a skill which can help with the query, and it loads the skill and it's able to respond with the information about the visa requirements. So this is Aspire dashboard again, and let's look into what's going on behind the scenes. So that's the user's message, and the assistant decides to load the skill called visa assistance. And yeah, so that's actually the extract from the markdown file. And then there was a subsequent call to load more data from the resource. And the agent actually responds with that information as well. And finally, the assistant is able to generate the final response. Now, let's look at the system instruction. And yeah, here, like you can see all the tools that's sent to the model. So it's the load skill and the read skill resource. And here you can actually see the skills that are sent in the context of the system instruction. And there is also an additional instruction that's added to the system instruction. So where it says you have access to skills containing domain specific knowledge, and that's added by our skill provider. So with this information, the model will be able to decide which tool or which skill it needs and raise the request for that. All right. So the takeaway here is skills make the system more modular and scalable, and you organize the knowledge into separate files and only load what is relevant to your current query, right? So this keeps the context lean and also simplifies your system prompt. And just a quick note, the skill provider is still in experimental stage. So there is a chance of some changes to the API in the future. All right, so now let's look at how to integrate tools to your agents. We'll focus on MCP tools today, but if you are interested in local tools, you can actually check out this sample here. All right, so as you know, MCP is actually an open standard for connecting AI applications to your external systems. It defines the protocol for hosting and also calling tools. And with this setup, agents can actually integrate with a variety of services without needing to write its custom integration for connecting to each one. So let's look at the execution path for using MCP server in this agent. In the setup phase, the agent connects to the MCP server, and it then pulls the list of tools and registers them in the agent. And in the execution phase, the user sends a query such as maybe booking a flight, and the age and it also includes the list of tools that are available, and the model decides to call the tool. And in this scenario, let's assume that an approval would be required to execute the tool. The agent would orchestrate the approval workflow, right, before executing the tool, and it would then call the MCP server to execute the tool and get the response. And the MCP server returns the result, and the agent sends that result to the model, which then generates the final response. All right, now let's look into the code quickly. So this is actually the code that we would be using. So it has a call to the MCP server, and it also has an approval workflow. So it's similar to the previous example again, and it also has a step for creating a MCP client. And the MCP server that we will be using in today's demo is also part of the solution. So there is a folder called MCP. It's a simple .NET Core application, and it's also deployed to Azure when we ran the ACD commands earlier. So to check that out, if you're curious to know how the MCP tools are set up, so it has two tools, one tool for flight bookings and another tool for searching for flights from the Cosmos DB. All right, so the first step is to connect to the MCP server, and we need an MCP client for it. And we use an HTTP client, a custom HTTP client. And because our MCP server is actually using an API key for authentication, we pass that in the header. And the next step is to actually pull the list of tools in the MCP server. And when you are getting the tools, you can actually iterate through them. And for the tool called book flights, we are using something called approval required function. So we are wrapping the tool call with an approval required function, which is the helper function that's provided by the framework. And this actually blocks the tool execution until the user approves or denies the request. And we then pass the list of all the tools to the agent. And when the agent responds, we look for tool approval request content messages. We look for messages of this type. And if we find any, then we initiate a request for tool approval. So we ask the user to approve the tool call in the console. And based on the user's response, we would actually add that response as a new message into the same thread. And based on the response, the agent will decide whether to go and execute the tool call or to cancel it. All right, let's actually see this in action. So let's start the MCP server. You can just say .NET run, and it would start the MCP server. And you can actually test this on VS Code as well. You need an mcp.json file, which has a configuration. You add that under the VS Code folder. You can open the chat window of GitHub Copilot. So here I'm saying find flights from Melbourne to Auckland. Just making sure that the tools have been selected. All right, so it executed the tool called search flights. And yes, now it should get the results and display that on the chat window. Okay, now let's execute the program. So it's able to bring the list of destinations. Sorry, the list of the flights for the query. And now let's comment this code and try the scenario for booking flight tickets. Right, you can see that it's actually asking for approval. And once we say yes, it would go and execute the tool call, and you see the response here from the agent. All right, so let's look at the logs on Aspire. So that's the request for booking the flight, and we see a response from the assistant or the agent for the tool call. And then when we approved the tool call, it adds a message into the chat history. with the status as approved. And now the agent will be able to go and execute the tool call, fetch the flight data, or sorry, book the flight, and come back with a final response about the booking details. All right, so you can actually use MCP tools to fetch data, and this is different from using a context provider. So with a context provider, the information is injected to the model's context before the model even starts reasoning. But whereas a tool is more dynamic and on demand, and the model decides during execution when it needs something and calls the tool to go and fetch that information. So there are slightly different ways of using an MCP tool and a context provider. All right, so now let's move on to the second part of the demo. And here we will actually be exploring two scenarios. The first scenario is a human in the loop workflow. So where an agent needs approval before it can actually complete a booking, similar to what we just saw, but this is from an application that's a React application. It's an end-to-end flow between your agent running on an ASP.NET Core application and your front end. So we'll see how we address that approval here. And the second scenario is about long-term memory. So this is where agent remembers user preferences across conversations and it delivers a more personalized experience. So we'll look at that as well. All right, so let me go and run this. And to run the program, you would actually use aspire run command, and this would build all the projects in your solution. And it also has a link to the dashboard. So you open the dashboard, and there is a link for your front end that you would click. So let's start with the human in the loop workflow. So I'm asking the question about finding flights to Wellington for next Friday. It's able to figure out the date and everything, and it's able to bring the results from calling the MCP server, the same MCP server that we used in the previous program. And you can also see that the results were displayed in a React card component. And now the assistant is also asking whether I would like to proceed with the booking, proceed with booking the flight. And now when I say yes, the agent should actually try. Okay, so maybe it needs the flight number. So I say yes. Now the agent would call the booking tool, and the booking tool will actually require approval. So it shows this pop-up for the user to respond to the request. And let's say yes. The tool call is executed and it shows a confirmation message. Now let's look at the logs in Aspire. So there are multiple tool calls. So here we are like searching for flights, and there is also a tool called display flight results. We saw that actually the results were displayed on the card component. So that's this tool in the front end, which is called by the backend agent to display the results in a card format. So we'll look at how the communication between the backend and the front end tools is established when we talk about the code shortly. Yeah, so this was actually the request for booking the flight. And you can see there was a request for the tool call and the approval. and the final response. Okay, now let's look at the long-term memory. So when we ask the assistant or the agent for help with planning a trip, it needs to know a few things like budget, travel style, and other preferences before it can provide the recommendations. So it comes back with this response. And once we provide those preferences, the agent generates a few options. So when we switch back to Aspire, you can see that it's actually using some skills in the backend to respond with an answer. Okay, so now if we come back later and plan another trip, you will notice that the agent would show you the recommendations, and it actually uses the response that was provided previously to generate the response. So it remembers, like we set the budget as $3,000, and we also had some preferences on the travel style. So it remembers all this information to personalize the experience. So it doesn't need to actually ask the user again for the same things. So let's look at the dashboard quickly to understand how this is implemented. All right, so the system message, if we scroll down, we see that the profile information is also added to the system instruction. So this is actually injected by a context provider, a custom context provider that we implemented called as user profile memory provider. And this is actually responsible for managing the user preferences as a long-term memory. Okay. So when you're actually building an AI application, it's not just about the agent or the model. It's also about the experience you provide to your users, right? So if you want the interaction to feel rich and engaging, you would not just work with plain text, but you would also have communication between your backend and your front end. So we saw that in the demo when the user asked for flight recommendations, the results were actually displayed in a rich card format and not as plain text. And when we wanted to book a flight, the user was presented with approval options in the UI to approve or deny the booking. And the key thing here is the front end isn't actually driving all these steps. It's the agent which is running in the backend, which is making all the decisions. And you can actually get a sense that agent is aware of the front end capabilities, and it's able to use that to create a more rich experience. And this is actually made possible through agent user interaction, or AGUI in short. AGUI is actually the protocol for communication between agents and the user interfaces. So, for example, in traditional client server applications, and the front end calls the backend, gets the response, and updates the UI. And that model will be too rigid for our agentic system. Agentic system needs much more dynamic communication. So they need to push updates to the front end as the reason, and stream responses, and also send messages to the front end for triggering any specific UI interactions, like showing a card or asking for approval, like we saw in the demo. Right. So this slide shows the step that we took when approving the request for booking a flight. The front end has a tool called as request approval, and this is actually sent to the backend. And the backend is now aware that there is a tool which it could use for the approval process. And when the agent needs it, it calls this tool, and this tool orchestrates the process in the front end, captures the response, and sends that back to the agent. And the agent can then decide whether to actually proceed with the tool call or not. All right. So let's actually look at the code. So the code for the backend and the front end is under the source directory. So let's look at the agent definition to start with. So this is where we define the agent. So if I scroll up, this is the system instruction of the agent. So it's simple. It's actually just adding a few rules to guide how the agent should behave when answering the questions of the travel recommendations. And yeah, the agent uses the same MCP tools, same MCP server. So we have search flight and book flight. And for book flight, we are actually using the approval function. Right, so we also add skills from the skills directory, and we create an agent. And apart from the skills provider, so we are also using user profile memory provider. So this is actually the provider for managing user preferences as a long-term memory. And this uses Cosmos DB storage for persisting the user profile. So if I go here, sorry, that's actually signed in. All right, so this is actually the Cosmos database. And under items, so this is how the long-term memory for the user has been persisted. So when we responded, it has captured the budget and also the interest that we specified in the JSON format. All right, so going back to the code. And the scope parameter, which is here, defines how the memory is stored and retrieved. And I'm using user ID, agent ID, and also the application ID as a part of the key structure. And this is to ensure that data is properly scoped and isolated for each user. So let's actually go into the user profile memory provider. And it's actually the same thing. So we have two methods, store AI context and provide AI context. The provide AI context method would actually read the data from Cosmos DB and inject that into the context. And store AI context is actually going to um, look at the chat history or the recent messages, and it's going to use a model to extract the user profile memory if there was anything that was discussed. And you can also see that I'm passing a model or a class here called user profile memory, and this would enforce a structured output from a language model, and it returns a strongly typed object that we could actually work with easily in our code. So you don't need to do all that passing on your own. Now let's actually look at the front end code. So before going to the front end, we look at how this agent is published. So we use dependency injection to register the dependencies like your chat client, your MCP servers, and also Cosmos DB client. And then we create an instance of the agent, and this is actually using the builder that we saw. We call the create method, we grab the instance of that agent, and then we publish that agent on AGUI protocol endpoint using this helper method called map AGUI. So any client that actually supports AGUI should be able to now use this endpoint to interact with the agent. Now let's look at the front end code. So it's here. I'm using Copilot Kit on the front end, and Copilot Kit provides built-in UI components for the chat interface and also supports AGUI protocol. I've registered the tools. We saw the tool called display flight results in the Aspire dashboard logs. So that's defined here. And I also have a tool registered for handling the approval workflows. So we have two React hooks, and again, that's a part of the Copilot Kit framework. Okay, so this is how it works end to end. And yes, let's actually go back to the slide. Okay, so in our current travel assistant, we have like a single agent that handles all the responsibilities, right? So it actually provides travel recommendations and also handles the flight bookings. And the quality of the response can start to degrade when the model has too much context or maybe like doing too many things. And just like how we apply a single responsibility principle in general, like in software design, we can apply the same principles to agentic applications as well. So this is where we can split the solution to use multiple agents and have each agent specialize in their own domain. And each agent can have its own model, instructions, and tools that are optimized to carry out its task. So Microsoft Agent Framework supports both agents and workflows. And workflows are essentially like, I mean, when you have multiple agents, you need still a structure to manage how agents talk to each other, how they actually share data and communicate. So you need an orchestration pattern, and the framework provides a few patterns out of the box like sequential, parallel, and also group chat. And you can also build your own custom workflow using the framework. In our travel assistant example, I'm using a handoff workflow pattern. So we have two agents. So one that focuses on travel recommendations and the other on flight related queries. And we have a triage agent, and this is actually acting as a routing agent. So this is the entry point. So it looks at the query and then decides which agent it should hand off the query to generate the response. So let's actually have a quick look at the code here. So we looked at how the solution can be built using a single agent, and this can also scale to use a workflow, right? So under the workflow folder, so you'll have the different agents. So we have flight booking agent and a trip advisor agent. So it's actually the same agent that we saw earlier, and we have split that, divided the responsibilities to these two agents. So you can actually see that flight booking agent has access to the MCP server for searching and booking the flights, and also the skills for flight booking. And the trip advisor agent has the skills for the trip planning and the visa assistance, and also it has access to the user profile memory provider. And we have a triage for the routing rules to decide like how to hand off to the specialized agent. And we tie all these agents in a workflow using the workflow builder class here. And we specify the handoff rules, like the triage agent can actually hand off to the trip advisor agent and a flight search agent. And we create the workflow, and we then I mean, this is actually a workflow, but you can actually consume a workflow as an agent and return this agent from the class. And to publish this agent's endpoint, we follow the same thing what we did for the individual agent. So we actually grab the agent instance and we expose that on the AGUI protocol. All right. So that's how you would actually scale from a single agent to a multi-agent solution. And let me just quickly show you a demo of it. So it's the same thing. We will not be noticing any difference in behavior, but you can actually see in the backend that it's able to orchestrate multiple calls and see the handoff also in action when we look at the logs in dashboard. So you can see that the first request goes to the triage agent. And that's the handoff. And it also has a reason why it's handed off to the other agent. And then it's invoked the specialized agent. And in this case, it's the trip advisor agent. And it's using the same skills and tools to come back with a response. All right. So with that, we have actually come to the end of our session today. And thank you so much for sticking around till the end. So we have covered a lot of ground and we started with the foundations of the framework. And we also did a deep dive on an end-to-end application to see how they all come together in a real application. So this slide has some resources that you could explore. We will also paste that on the chat for your reference. The GitHub repo has samples in both Python and C#, and I highly recommend cloning it and trying the examples to get more hands-on experience with the framework. And the documentation is also a great resource in case if you want to understand different concepts of the framework and also like understand the concepts of building agentic applications in general. All right. So your feedback is really important for us and it helps the team to meet your needs better. So if you could please take a moment and scan the code on the screen to fill out the form, it'll be much appreciated. You could actually tell us what you like to see more in the future sessions. And if you want us to do a deep dive on any of the topics that you would be interested in, we will be able to meet that. Just leave there for a few seconds. Okay, and just a quick reminder that this is the first episode of the AI Genius series, season 4. And we also have some great sessions that's lined up in the coming weeks. So you can actually scan the code on the screen to view the details of the session and register for them. Okay, right. So congratulations, you have earned yourself an AI Genius certified badge today. And you can actually claim the badge by scanning the code and posting that on your LinkedIn profile. Okay. All right. So thank you so much for joining us. And I really hope you found this useful. And apologies if it felt a bit rushed at times. And there was actually so much content that we had to cover in this session today. Thanks again. And yeah, so let me jump over to the chat and see if there are any questions for us. Okay, just actually looking at the chat. Yeah, so there is actually a question from Mohan. Can we access agent usage in Agent UI? So with yeah, so with actually when you expose this agent as an OpenAI compatible endpoint, it also has additional information like how many tokens have been used. So you can actually use that in case if you want that information for your client. Right. So just checking if there was any other question. Right. And after deployment, how do we access the logs and traces? So you can also use uh, Aspire dashboard on your Azure as well, but it's mainly for the development uh, workflow. On Azure, you can actually have the logs being saved in Log Analytics workspace, and you can actually use the Azure Monitor or App Insights to view the same traces that we saw now in the demo. All right, I think, yeah, there was. All right. So long-term memory is actually the memory that you would need across sessions. That's actually the data that you would want to persist so that you can generate a more personalized experience for the user. So in our demo, we saw that we were persisting the travel style, and we were actually persisting some of the preference for the user for the flight and the travel requirements. But in case of short-term memory, it's all the memory that would be required to answer the questions in that one session. So uh, if you open new thread, that short-term memory would be lost. So it's actually the providing a more personalized experience. All right. I think that's pretty much it from me. Thank you so much, everyone. Thanks for joining us today. And yeah, enjoy the rest of the day. Thank you.